X-rays are a form of electromagnetic radiation discovered by William Conrad in 1895 while working on the effect of cathode ray. He noticed the tubes were similar to our fluorescent light tubes. He evacuated the tubes of all the air, filled it with special gas, and passed a high electric voltage through it and discovered a new form of light, X-rays. We now use X-rays for many conventional and medical reasons. The frequency of the wave is 3x 10 to the 16th power and 3x 10 to the 19th power, and the wavelength of the wave is 0.0 nanometer and 10 nanometers. Uses. X-rays play an essential role in many of today's medical advances and securities. We use X-rays to see inside of people. For example, if someone has a broken bone, an X-ray will be able to see that because the waves can pass through tissue and are blocked by bones, and produces an image of the bone. We also use an X-ray for airport security and other types of security. It can be used for security because it shows anything that the X-ray didn't pass through, and it's a lot quicker to use X-rays rather than just going through people's stuff. It can pass through clothes, tissue, basically anything that would normally be on a person, but it can see them. It's just more vague looking. The thicker things are, the more darker and are more detailed images. X-rays can also be used by astronomers. Many objects in the universe produce X-rays, such as stars, planets, and many other things in space and on Earth. We can dedicate these waves by using a suitable radio telescope. Adam will now demonstrate on how to solve an X-ray word problem.
So the problem is an X-ray light has a frequency of 3 times 10 to the 17th hertz. What is the wavelength of the light ray? So first, the problem that we use is V equals frequency times wavelength, and the speed of light is always 3 times 10 to the 8th. And we know that the frequency is 3 times 10 to the 17th. So we just do 3 times 10 to the 8th divided by 3 times 10 to the 17th equals 0.000000001 meters. And for the next problem, we have an X-ray light has a wavelength of 5 times 10 to the negative 6 millimeters. What is the frequency of the light? Again, the speed of light is 3 times 10 to the 8th. And the problem is speed equals frequency times wavelength. And the wavelength is 5 times 10 to the negative 6. And so we divide 3 times 10 to the 8th divided by 5 times 10 to the negative 6th. And we get
0.01 to 10
we get 6 times 10 to the 16th hertz. As the frequency.
And that's it. Interesting facts. When X-rays are passed through the body, some waves pass through the tissue and turn the film back. Other waves are blocked, which leaves white shadow on the film. Each kind of tissue lets X-ray through differently. X-rays were initially thought to be safe until scientists and others who worked with them began mysteriously dying. It was a Marine Corps work that would lead to safety advancements in the field of radiology and radiography. Conrad was mystified by the radiation he had discovered when he discovered X-rays, so he temporarily called them X-rays, with the X being a mathematical symbol for something unknown. Although he objected, the name stuck through X-rays are occasionally called Roentgen rays in German-speaking countries. The first known human to be killed by X-rays was Clarence Dowley, who had spent a number of years working on Thomas Edison's X-ray light bulbs. After years of work, his hair fell out and his skin erupted in lesions that wouldn't heal. While Edison canceled the bulb, Dowley continued working with X-rays. Burns on his hands became cancerous, and he had both of his arms amputated. He died in 1898 at the age of 39. Here are our sources.